Good morning. First of all, I want to thank the organizers for inviting me. It was a good trip to come out here from the West Coast and come to Waterloo. Something I've heard about, and I'm glad I'm here. One of the first things I'm going to do right off the bat is tell you I'm brevity challenged, so I'm going to stick to the script when we start, because if I don't, we'll wind up with people flashing cards and doing all kinds of things to tell me to get the hell off the stage. So I'm not going to do that. Let's just jump right in. All right, so this morning I'm going to talk a little bit about how we get, based on the BC experience, how we reduce the gap to zero waste. Our system in BC, and I'm going to give you a fast overview of it. I keep hearing from a lot of people how we have done such a magnificent job in BC and it being a global leader in terms of its EPR programs and the rest of that. And to a certain extent, I wholeheartedly agree with it. I've been involved in that process for a good portion of the 30 years. So let's do a fast review of what BC is. We've got this nifty little red map on here as to the province, and thank you very much, Joe, for helping me with that. 925,000 square kilometers, 4.7 million people. We're not quite as big as Ontario in terms of people. We have an interesting structure in terms of regional governments, which are an aggregation of municipal and cities. 28 regional governments throughout the province, incorporating 162 municipalities. 52 of them have been designated as cities. The province regulates EPR programs, including the plan approvals. Local governments can operate facilities. They don't necessarily have to, but they can. They can implement disposal bans. And I make a point of that. Disposal bans are not product bans. And that's important when we get through a little later on in the conversation. BC EPR program targets are results-based. Here's where you're supposed to be. This is what we expect from you. And then the brand owners assume 100% responsibility for getting the plan in place and operating it. Here's the current list. I don't know that it's dramatically different than anybody else's, but we've got 25 programs that are on the go right now. Every 5 years, each of these programs has to go through a program review, an update, and a reapproval. We've just finished, I think 3 of them are just finishing that. They're in the stages of it right now. I've highlighted 2 because that's the story I'm going to talk about later. The interesting thing is there's a couple of these programs, tires and used oil. The dates that are shown here are sort of the reissue. The original programs were, for all intents and purposes, consumer put money into the pot went into provincial general revenues, and the province was in charge of running the program. I don't have to tell you that it didn't work very well. The dates that are on here is when they reinvented the program, turned it over to 100% EPR with the brand owners responsible. Now, in terms of the future, CCME has suggested some future programs. The ministry, when I talk to them, they don't have any set timelines or dates for when they're going into these things. They're there. They're looking at them. Some of them are going to come on sooner than later, but there's no real time set now. The interesting thing is that while most people suspected construction and demolition waste would be sort of the next item, there's been a couple of interesting reports come out, including one that was done in terms of the Strait of Georgia and ocean waters between Vancouver Island and the mainland. And one of the things that they found is that a significant portion of the samples, the contaminants that they found in there were not things like polystyrene or polyethylene. They were, in fact, microfibers from synthetic textiles, probably a result of washing machine discharges. So my guess is, with the world being where it's at right now, I wouldn't be surprised to see that textiles would be sort of the next program if they go into it soon. How successful have we been? This is numbers up to the final annual reports in 2017. I'm not going to go through the whole thing other than the fact that it's interesting to note that the packaging and printed paper, which is for all intents and purposes 3 years, we've gone from 0 to 100,000 tons a year, which I thought was very well done. So now I'm going to tell you a little story. When I was in school, I had a university prof who believed that he would ask you these really nifty questions, and the answer that you gave him had to be a story. So I'm going to try and tell you a story. In 1970, BC put into regulation, into legislation, an anti-litter bottle deposit. Now, we've had bottle deposits. As a kid, I'm sure you got 2 cents back for a bottle. If you went to the corner store, he probably made you buy candy or something for the 2 cents, and then ultimately he turned that bottle into the beverage supplier, who exchanged that bottle for one that he filled and used. So it's not that bottle deposits were new, but this one actually codified the fact that there had to be. It covered a relatively small list of containers of beverages, and it wasn't a real EPR program. There was no definite organization. There was no reporting process. It just was there. And it helped reduce litter. Second chapter in the story, 1994, Encore Pacific was established. Create a province-wide network of depots to manage used soft drink containers. Now, depots in BC were originally a real mixed bag. They had all kinds of various little operators. There was no real organization to it. Encore came in and changed all of that. They put together a set of operating principles. They paid for the services. They created a professional depot operation. At the same time, and this is the point of this whole story, at the same time, a little plastics recycling operation that had been going on for probably 8 or 9 years wound up signing a contract with Encore to process and market the plastics coming out of the beverage container system, Merlin Plastics. He moved from what was in the beginning a garage. It wasn't really a garage, but it was that small. And in 1995, they moved into a 60,000 square foot facility and installed a really, at that time, innovative and progressive processing line, including color sorting. Nifty stuff in those days. The same time, as people who know Tony and know Merlin, it allowed him some flexibility in terms of his ability to play around with some other things. And he's established a good reputation in terms of willingness to attempt and try things. Chapter 3, Recycle BC. Originally Multi-Material BC was established to fulfill the requirement under the recycling regulation to manage residential packaging and printed paper. Wow. Open the cupboard in your kitchen, look at the shelf. Practically everything that's on that shelf in terms of packaging is now going to be managed. At the same time, guess who signs a deal that incorporates Merlin, and he now winds up in a scenario where he's going to be the processor, the marketer, for a program that gathers 185,000 tons a year, services 1.25 million homes, and Green by Nature spends the better part of $32 million. 20 of it goes into a new container reprocessing facility. They wind up where they set up 200 people, some of which were part of the Encore system and some of them that were new. They set together with 32 facilities to do the collection and consolidation. The point of the story is this. If we're talking about getting to zero waste, there is no easy way to do it. It's complex. It's not going to happen instantly. It's an iterative process. We're going to have to go at it one step at a time. In order to do that, I told the story because it shows you that when we have policies in place that allow stewardship agencies or operators to have some security that reduces the risk in terms of their investments, in terms of the feedstock supplies, and the duration that they're going to get those supplies, operators will make the investment, they'll put in new innovative equipment, they'll set up new innovative operations, and they'll push the peanut further up the hill. They will aggressively go about it because there's a security in doing that. There's a sense that, in fact, they are part of moving forward and they can afford to do that. That's how we're going to get there. What's one of the other things we have to have? And this, I struggled with the next couple of slides here because there's been some events in BC that are really, I honestly believe that we have a very good system in BC. I think that the ministry and our politicians and our bureaucrats over the last 25 years have done a good job in putting that system together. But you have to have an ongoing. There has to be a strong level of understanding of what the system is and a commitment to science-based decisions. Not just by the bureaucrats. You have to have elected officials and decision makers in a knowledgeable state. They have to recognize that if you have a system in place, it has to be flexible enough that you can take the advantage of new innovations, that you can bring new things into the system, that you're not just, we talk about reduce, reuse, recycle, recover. That's good stuff. But if we stay focused on just exclusively what we started with and we're going to put it right back into the same thing, the apples to apples only approach, we're not going to get any further ahead than we are right now. We can't. Because while the rest of the world and the packaging requirements and the science around us are moving forward, if we restrict this industry, this operation, to doing what it did yesterday because that's the only thing that's right, how can it do better? So you have to be in a position where the people who are making the decisions with regard to policy recognize that they have to leave the doors open to allow operators and the systems to try new things. I hear stories about the technologies of things like Green Manta or Agilex, and the fact that there's a resistance by policy decision makers to ignore that, or better yet, say, no, that's wrong. How can we talk about solving the problem when we turn around and say, well, we're not going to do that because we don't like it? If science puts us in a position where we can solve a problem, we should be listening. We should be looking. And we need to make sure that the decision makers understand that. And just to wrap it up, I'm going to tell you what I think is the biggest flaw in the system in BC. And I am so guilty of this one, because up until 3 days ago, if anybody had said to me that, in fact, there could be decision makers who could upset the balance of the whole system. We've had a series of events, City of Victoria, City of Vancouver, who are deciding that despite the fact that we have extended producer responsibility programs, we have stewardship in place, materials are being managed within that system, they don't want those materials in there. They're going to, City of Victoria, going to ban plastic shopping bags. They're part of the extended producer responsibility program. There's 300 return points that return to retail. There's depots. It was part of the existing program. When I talked to the ministry about what the city was doing 2 years ago, their attitude and mine was, this is part of the environmental policy. The province is responsible. Remember in the beginning when I said province manages environmental policy within expanded producer responsibility programs. City can operate, but they don't have. Wrong. If anybody had told me that there was a possibility that the city could step outside the provincial program and decide that they're going to go their own way, my answer would have been, no, they can't. Unless they get approval from the minister, it can't happen. On Tuesday of this week, it can happen. City of Victoria is going to ban plastic shopping bags. Over and above provincial authority, they now have the authority to do that. It's not under the environmental legislation, it's under a business, municipal portion of their charter. But it now puts us in a situation, this is a municipal election year. Can you see what this summer is going to be like with a whole series of politicians who want to get to be elected? This is just absolute. We're going to have a lot of action out there. And the problem is that if, in fact, each individual city, we have 162 individual political entities as cities or municipalities. How the hell do you run a provincial program with 162 different versions? The answer is it's not going to happen. So in one fell swoop, 25 years, that long? Gee, I'm doing good. 25 years of hard work and commitment on developing programs that really are recognized for being among the best. By the end of this year, we could be in a situation where we don't have one provincial program that works. We could have 160 some odd of them that don't. So the biggest flaw is the fact that we, those of us who were very smug and thought that the program was so good nobody could screw with it, excuse my English, that it did. So the biggest key, I think, to being successful in all of this is the fact that we need to keep the communication doors open. We need to make sure that the information and the knowledge, as it flows and changes and moves forward, that our decision makers, our policy makers, and our participants, we can't turn every individual resident into a recycling expert. And when Steve was talking about his 10%, 80%, for years I've said it's 15, 15, and 70. There's 15% of the population that isn't going to do whatever it is they're supposed to be doing no matter what we do. But if we can get the other 85, we're doing very, very well. But to do that, people have to understand what the system is. I mean, part of the problem we had with this whole business with the City of Victoria was there was a bunch of people who really didn't understand the system. They had no idea. And when Mr. Hariska and I talked to the City of Vancouver, there were several people there who were making decisions at the political level, who, when you talked to them and explained how the system worked, just looked at you with a blank stare. They had no idea. We can't have that. Because otherwise, we're just going to spin our wheels, and every time we turn around, every 4 years there's an election campaign, somebody's going to come up with a great idea that we're going to do something different. Not going to work. Thank you.
Today I'm going to talk to you about the UK's change in waste management. We used to be a landfill-dominated country. In the last 20 years, we've gone from being that to being very process-orientated. And this is really the journey that we've been through, and really how MBT particularly has fitted into that journey. So let's talk about, first of all, the drivers. There's two really key ones. And probably the most important one was the Landfill Directive, EU directive. And as part of the European Union, as we still are at the moment, we're bound by those directives. So the UK was duty-bound to divert or reduce from its 1995 levels of 80% biodegradable waste went to landfill, down to 35%. Massive challenge by 2020. We also, on the following year, 1996, brought in a landfill tax regime. So landfill was incredibly cheap in the UK. It was abundant, it was cheap, it was our preferred disposal solution. So it came in at $3.50 a tonne, really quite small, but it was due to escalate every year above inflation. So it was a change mechanism. So you had a fiscal mechanism and a legislative mechanism to change. So there were the two key drivers. How are they to be delivered? The government body, DEFRA, introduced the Waste Infrastructure Delivery Programme. This was a mechanism to attract the private sector into building infrastructure that would support local authorities. So projects that DEFRA asked local authorities to come forward with deliverable projects that would divert waste from landfill to help ultimately the UK meet its landfill directive targets and avoid infraction proceedings. So by that, a successful project was one that seemed to divert waste from landfill, but ultimately the private sector take on some risk. So it was delivered through the PFI mechanism, or PPP, Private Finance Initiative, or public-private partnerships. So through those, the private sector really took on, in my view, far too much risk. We took on full composition risk. So the councils could bring us anything they liked in our residual bin. We also took on full disposal risk on all the products. So we had to market any products we produced and make them sustainable. So that was really where we went to at the beginning. Since then, we've had Zero Waste Scotland. So Scotland has its own parliament. They have some own policy, and they're boarding a Zero Waste Scotland policy. So there's a ban on landfilling biodegradable municipal waste by 2021. So some significant drivers in the UK to drive us away from that change. So where have we got to? 22% of our baseline is now landfill, so it's a 1995 baseline. Our landfill tax, incredibly, is now $155 a tonne. So you can see landfill is now very expensive. So that was one of the key drivers of change. The WIDIT programme brought forward 92 projects. 81 have been built. So not all were successful in that process. Of that, we've built 60 million tonnes of capacity to treat waste. And of that, 4 million tonnes of MBT capacity. So it's a big part of it, but not a significant part. Some of the other 60 million tonnes of the 60 million tonnes is energy from waste, some burning some of the products from the MBT facilities. So there's a cover over there. I think what we're seeing now is some new things. The EU Circular Economy Bill is now in place. How that affects the UK will be interesting as we leave Europe. But I think there's some drivers there that will come across to the UK as well. So I think that whole piece around how we use materials again is centre in terms of the decision-making process, certainly at a government level now, more and more at a local authority level. The Blue Planet, you may have seen that, David Attenborough's programme, looking at plastic pollution in the sea, had a seismic change in people's mentality to waste. immediately we saw people saying we want to ban things. So McDonald's have banned straws this week I've seen in their things. They're going to paper straws in the UK. Government's struggling to keep up with the pressure from the public to do something. We've seen it in our MRFs. We've suddenly seen a seismic change in the volume of material we're seeing coming through the clean curbside collection systems. That's also affected the MBTs in terms of reducing what we see there. I think one thing, though, that really affects us is the quality of the materials. It's all well and good recycling things, be it from a clean source separated, or from an MBT source. It's what do you do with it? And I'll talk more about that in a minute. So quickly, what is MBT? It's a bit of a panacea name, really. It's a number of things. I think the way I look at it is just a system of technologies, a group of technologies, with mechanical separation, some form of biological processing. You can see there we have aerobic fermentation. So that's biodrying. So we can dry household waste to produce dry fuels, high-quality fuels, that we can then put into the secondary market to substitute coal and gas and oil. Composting, so we can actually stabilise the material. That's where MBT came from originally. Germany was very much stabilising the material before they put it to landfill. We can have anaerobic digestion, both wet or dry. Heat treatment, thermal combustion, pyrolysis gasification, a number of technologies fitting together to form an MBT process, producing a number of materials from recyclable materials back into the secondary market, stabilised MSW, potentially as a pre-treatment to landfill, solid recovered fuels, refuse-derived fuels for different types of combustion process to recover energy, compost or digestate, heat, electricity, syngas, biogas, chemicals. It's an enabling technology, and I think that's how you should consider MBT. It's a step change technology. It allows you to develop, as your systems develop, technologies come along, you can modify the processes around this to produce different products, different systems, different processes. Quick look at some examples of some of the MBT projects built in the UK. We'll start with Derby, this one here. It's a plant that's 190,000 tonnes. It is right in the middle of the city, right next door to Rolls-Royce, so one of the biggest employers in the city, so very sensitive neighbours. So you have to operate it in a way that doesn't cause smell, odour, flies, nuisance, anything. It's a plant that's just about coming out of commissioning now. So it forms dry separation, has a biodrying step to biodry the residual fraction. Why? We then mechanically refine it to recover metals, glass, some forms of rigid plastic, and a small amount of different types of film plastic, as we heard about earlier on this morning. The residual piece left over is then gasified through a 3-line gasifier train. So quite new to the UK in terms of this system, and there's 3 plants like this currently under construction in the UK using gasification to treat the residual fraction. If we then look at the next plant, Wakefield, there's a number of facilities on this site, but if you look at the 2 facilities on the very bottom, we have here dry separation, so the residual fraction separated again to recover some plastics, an RDF fraction. But what we're really interested in recovering in that plant is an organic fraction. The organic fraction is then further processed using a steam autoclave to break the fibres apart, deal with polystyrene bead, make it very easy to separate and put through a wet AD system to recover electricity and energy. The final digestate is put to land and land restoration, so a closed loop of getting materials back to land. The RDF fraction is burnt at a purpose-built plant that serves a number of these contracts to dispose of the RDF fraction. The next one is a different authority, 3 authorities actually. It's Barnsley, Doncaster, Rotherham, in the heart of the coalfields in the north of England. MBT, again, using biodrying here. They're really interested in producing an RDF fraction to burn in a large combustion plant nearby. So it's shredding, biodrying, mechanical separation. Again, plastics are recovered from this. Metal and stone, metals are recovered. Glass and stones are recovered back to the secondary aggregate market. So a number of different fractions. The organic fraction we recover there goes through a dry AD system. So again, we recover the energy from that process, and the energy is used on the site or exported to the grid. The organic fraction is used in land restoration on some of the old colliery sites. The final one's a very different scale. It's a place called Dunoon. It's on the west coast of Scotland. Incredibly beautiful place. It's only 14,000 tonnes. This is a very rural community, so there's a long way. It's 100 miles to any significant population centre, Glasgow. So you have to deal with the waste locally. You can't haul it for the haulage costs. So it's on an old landfill site. So it's dry separation, in-vessel composting of the organic fraction separated. That organic fraction is used in the restoration of the old landfill site as part of the restoration medias. The stabilised materials, the other bits, the remaining plastics are landfilled, significantly reducing the environmental impact on leachating gas from that landfill. So it's a very local source, very small, very simple. So you can see from this, MBT covers a huge range of different technologies and systems. There's just 4 projects in the UK, there's dozens of more. They're really there to address what the authorities wanted. Under that WIDIP scheme, the one key thing that the government said was, you can do any technology you like, councils. You have the choice, so suit your local market. So some would try and go for incineration, some would go for MBT. So it really was allowed for the market to decide, or the authorities to decide what they wanted. So quite a lot of freedom to suit their political needs, their geography needs, and the desires of the local communities. So there is obviously some advantages and disadvantages of all technologies. So let's just look at what MBT provides first. I think it's a flexible technology system. You can change it. It's relatively flexible, even for changing composition, and certainly some of our projects that are now into year 15, we've seen significant changes in the composition of the materials coming into these plants. So how do you manage that through a process? The configuration will need to take account, there's obviously the output market might change, so the materials you produce may no longer be acceptable in terms of specification. So you've got to allow a process to be flexible. And I think MBT allows you to modify, tweak, change, add new equipment, take equipment out, change your process. It's really quick to deliver. We can get these built, MBT plants in the UK, in probably about 18 months from start to finish, including permitting. There's energy from waste projects in some parts of the UK are taking 10 years to get a permit. That's before you start. So some real challenges around EFW. EFW, mass burning EFW in the UK has been challenging to develop. I think less so now as the market's changed. There's more acceptance of EFW technology, and certainly the myths around all our children are going to have 3 heads have gone, largely. So it's easier to deliver energy from waste now. But in the early days, it was very, very difficult. So really MBT was seen as a solution. I think it can be considered an enabling technology. It allows us to change and modify, and that's its real strength. And it can increase recycling performance. We can recover reasonably good quality plastics. We can recover glass and stone. We can look at other materials as the process develops and the markets develop for those end products. What it's not, though, is a few things. It's not an end-of-pipe solution. Not like an energy from waste plant where you put it in, all you've got to dispose of is ash. We have products here we now need to market, we need to find a home for, we need to develop markets. A real challenge in an emerging economy where you're using MBT for the first time, and that was one of the real challenges for us developing MBT in the UK. It doesn't produce high quality materials in terms of recyclables. It can't. It's not source separated. It's jumbled together with everything else, the food waste that wasn't scraped off the plates, batteries, you name it, dead whales even, believe it or not. In one case, all sorts of things end out in people's bins. So whatever's in it is in it. So it's very hard to separate that from a very mixed stream as opposed to even a commingled stream from the dry recyclable fraction. It also doesn't produce high quality compost. In the UK, it's still a waste. So even our compost, which are reasonably clean, they're free of plastic, they're free of glass, there's still other things in there, metals, heavy metals, but also some other unknown contaminants. So in the UK, it's banned to apply them to any land that is agricultural land. We can only use them in landfill restoration or restoration projects or non-food crop for growing biocrops, things like that, biomass crops. So a real challenge in terms of what you do with the compost fraction. So what do we need to drive the market certainty? And this is clearly the thing I think challenges our sector the most in terms of where MBT now goes. We need sustainable revenue streams. We took the risk at the end of these contracts. They're 25-year concession contracts. What do we do with this material for 25 years? So it's either a back-to-back relationship or you're in the market trying to find new relationships. So the operator needs to make a return. Clearly, we don't do it. We're not a charity. But the off-taker really needs to see value in the product. I'll give you examples of that. We supply quite a lot of SRF to the cement industry. The cement industry said, yeah, we'll take your SRF. 2 years on, they're saying, those long bits you get in there, we don't really like those because they block the pipe. And the CV, we said 16, but actually we want 18. And the price, yeah, we want a bit more for it, thanks. So we're paying for disposal. So you've got to manage your markets. So some of the challenges around, how do you deal with that market? Quality will always improve. It won't go the other way. So when you start with a new product, everyone wants it slightly better. So the challenge around what is. So you're looking at CV, you're looking at chlorine content, looking at those non-contamination issues you have with it. So trying to really drive that market. Organics is a really good one. We've got back-to-back contracts with some off-takers and restoring old collieries. You know, the UK had a massive coal industry. It has no colliery deep mine coals anymore as of last year. So we've gone from, in 20 years, having 700 coal mines, I think, to none. So there's lots of shale tips. So at the moment, we have a ready-made source for restoration media material. So our output for our media is very, very simple, actually. That's used as part of the restoration media to restore collieries. We're growing biocrops on some of those now, so biomass crops for secondary combustion or even to synthesis for ethanols. So some innovation coming there. So really, again, it's the thing that drives that the most is strong regulation. We need the government to help us. We need to say, you know, an SRF looks like this, rather than someone who can make it very differently or not of the same quality to disrupt that market. So it's about support to the market to allow these long-term contracts, municipal contracts to survive. Policy drivers, supply side, quality, volume, product focus. Really key things you'll have heard before. Demand side, we want quality, we seriously want it affordable, but we need to be compliant too. So you ask the cement sector, you know, their chlorine at 0.4 is okay, they're rather at 0.2. So there's always a challenge around how you help them keep compliant. Innovation, new products. We're starting to look at some of the output streams, particularly organic fraction, actually, looking at synthesizing for ethanol production and something like that. The challenge of that is it's about market certainty. You know, it's difficult to get funding for new projects where there's a research project going on. So we've got to develop these technologies to allow us ultimately to drive a change in the market, to allow us to use some of the materials we make in a different way and get them more into the primary market. So in summary, what do I think of MBT? I think it's a flexible solution. It's a group of technologies that can configure to meet desires of many things. So where you have authorities with different desires, different economies, different population centres, population densities, you could apply this group of technology, I think, across a wide number of different solutions. Cost effectiveness. It all costs money, this stuff. It's not cheap. You know, you can have an MBT plant costing you $2 million up to $200 million. It just depends what the configuration of the equipment is and the size of it. So you need some kind of legislative framework as in why do we need to change, and probably a fiscal one, because ultimately if landfill is so cheap, why would you drive away from landfill in the first place? Key thing, products are absolutely king. The success of MBT is all around what do you do with the stuff you make. It's just that interim step. So you really need to understand what am I making from this process, what is my market for that process, and how do I develop that market for that process? Thank you.
Good morning, everybody. Let me thanks the organization for the invitation, and in particular Professor Franco Beruti and SIFAR for this opportunity. I'm really happy to be here today. The focus of my presentation is about flexibility of a gasification process when it is used to resource recovery from waste. Then I believe in agreement with the aim of this session. I will try to describe some case studies of waste valorization by gasification. Let me start from the beginning. This is the well-known definition of the thermochemical conversion processes, the combustion, where fast and complete oxidation produce a flue gas with only completely oxidized products. Gasification, which is the focus of this presentation, where a series of endothermic reactions in presence of gasifying agents produces fuel gas which contain large amounts of not oxidized products. This can be utilized in different sites in different time. Look at immediately at the flexibility of gasification process. It is able to treat different feedstocks with different gasifying agents, producing different products that can be utilized in different sites and in different times. Simply speaking, the gasification of waste of biomass and also coal leads to the formation of a producer gas, which is an amount of mixture mainly of carbon dioxide and hydrogen with some percentage of methane, with different impurities in terms of organic and inorganic compounds. In a simple, the main aim is to convert the chemical energy contained in the waste into the chemical energy and sensible energy of the producer gas. It has a number of important aspects that increase its flexibility and in particular when compared to a conventional direct combustion. This is a list of this. And in particular, gasification has the possibility to have a large, wider fuel flexibility and a large range of possible products. Look at, beginning at the large flexibility in input. It is possible to gasify biomass and municipal solid waste, but I will describe today that there are commercial scale plants that are able to gasify bottom mesh from conventional waste to energy incinerator, mixed waste from mechanical biological treatment, sewage sludge, and reclamation waste. There is also a large flexibility in output because of the fuel gas which is obtained from gasification process can be sent based on the level of cleaning of this fuel gas to a boiler, to a gas engine, to a gas turbine to produce electricity and district heating, but also chemical synthesis with a certain number of secondary products. This slide, in my opinion, gives a good idea of the incredible large and input and output flexibility of the gasification process, because after the collection and the conditioning, gasification can immediately, the fuel gas produced by gasification can immediately co-fire the industrial kilns in the production of bricks, cement, steel, lime, or can be sent to an organic ranking cycle or a drying application and then recover energy. Can be cleaned to be sent to a combined heat and power unit, or can be also further conditioned to produce fuel for transportation of chemical industry. An example of this large flexibility input is a plant that I hope to have time to describe today, where the gasification, indirect gasification, is utilized to produce a syngas that is then sent to a methanation synthesis and to produce biomethane from biomass and biowaste. This is the technical feasibility of this process has been demonstrated in a Swedish project that has been concluded a few months ago at the end of March of this year. This incredible flexibility allows also polygeneration strategies, I mean the production of more than one product in a combined process. This is a list of this possible strategy. Obviously, there is a higher cost, investment cost and maintenance cost, but there is also the possibility to follow the changes of market demands. I would like also to just, I'm smiling because it's a project that we are preparing with, that involves a number of Italian universities. And there is, again, the possibility to utilize gasification after the syngas cleaning to follow two possible production, biomethane from the process that I showed before, or the production of bioplastics by a fermentation system. But there is also an idea to evaluate the possibility to a more complicated combination of treatment of wet biowaste, semi-dry biowaste, and dry biowaste, and utilizing biological treatment, different kind of biological treatment, thermochemical conversion to produce, as an example of polygeneration strategies, biomethane, bioplastic, electricity, and so on. In other words, this large flexibility of the gasification process indicate, for waste-to-energy, for waste-to-fuels, or waste-to-products, suggests that the gasification could be one of the best processes to open the way to a carbon recycling economy that is a little bit different from a recycling economy because it's more transparent, there is no more, and I hope to have the time in these 2 days to discuss about the necessity of transparency when we speak about the recycling economy. Let me spend a few minutes about the possibility, the type of gasification process that we can use. There are direct gasification, called also autothermal gasification process, and indirect gasification, called also allothermal processes. The first the heat necessary for the endothermic reaction of gasification are produced by the partial oxidation of the waste of the biomass in the gasifier itself, depending on the type of the gasifying agent, air, oxygen, enriched air, or pure oxygen. It's possible to have different heating value of the obtained syngas until to obtain a mixture which could be a good basis for production of transportation fuels. In this case, the energy for obtained from partial oxidation is utilized for 5 or 15% for drying and pyrolysis stages, and the rest for the gasification reaction. In this case, it's the main parameter is the equivalent ratio, the ratio between the oxygen really fed to the plant and that necessary for the stoichiometric combustion. And we are not more oxidized products, but a mixture of CO and hydrogen. And we work in a range between 0.25 and 0.5 to obtain the best mixture of possible fuel gas. In terms of specific enthalpy, this means that we will work in BE under the carbon boundary to avoid any presence of charring into the gasifier and to utilize a part of the chemical energy of the gas to produce the energy necessary for the endothermic reaction. The other kind of gasification, the allothermal processes, are very, very interesting for the production of chemicals or for the production of transportation fuel. In this case, there is no, the process include only endothermic reaction, and then there is a necessity to obtain energy from outside, from external sources. The best way, the gasifier agent are steam or carbon dioxide. One of the system is that to combine a bubbling fluid bed gasifier with a circulating fluid bed combustor. In this gasifier, steam produce the fuel gas, the char, the unconverted char is sent to the combustor. Here the combustor is burned and the bed material, the hot bed material is moved from the combustor to the gasifier in order to transfer the necessary energy for the gasification reaction. This system has been demonstrated as technologically feasible in a large plant, 20 megawatt of biomethane production. The other possibility is that to utilize plasma gasification. In this case, the external sources, recirculated hot solids or plasma torch, produce the energy necessary to the endothermic stages, and the key parameter is no more the equivalent ratio, but the steam to biomass or steam to waste ratio. Also, in this case, we work in a large range of this parameter. There is no decrease of the gas chemical energy because after the carbon boundary, there is more steam added, and then the water gas shift reaction increase the quantity of material of the gas chemical energy in the produced gas. Another type of very interesting gasification is the co-gasification process, and that means co-feeding of different material to improve the process performance, particularly in terms of syngas energy content. But in the case of waste, which is very important, also based on the good experience obtained in Japan in the last 15 years, to increase the role of thermal treatments in a sustainable waste management system, I mean in terms of allowing the possibility to treat difficult materials, to minimize the final amount of residues to be sent to disposal. This is a list of possible material that can be co-feed. Obviously, it is necessary to choose appropriately the blend and the blending ratio in this kind of process. And I conclude this sort of introduction with this taxonomy of gasification process that show the type of direct and indirect gasification, the type of gasification agents, the final application, the different color indicate that, for instance, waste to fuel or waste to production need a necessary an allothermal process with steam or carbon dioxide. The yellow waste to resource can be obtained also with a autothermal system. I want to show you two main case studies. One refers to the leading, most proven technology in Japan and in the world, which is called the direct melting system. It is a particular kind of reactor, vertical shaft reactor, with high temperature at the end of the reactor, 3 zones where there is the drying and preheating, the thermal decomposition, the combustion of the ashes. This system works with no pre-treated waste. This is a lot of economic saving. With the introduction of a certain amount of coke, about 40 kilograms for each ton of waste, and some limestone. The possibilities where the system have been designed in Japan to work with municipal solid waste together with sewage sludge, bottom ash, landfill waste, chemical waste. The high temperature obtained at the end of the reactor allow to obtain melt slags that can be immediately recycled. Why? Because, let me briefly indicate the reason. First of all, this coke bed layer increases the temperature at the bottom until 1,800 degrees C. This allows to utilize a wide range of treatable wastes, and bottom ash from conventional incinerator, glasses, iron, and so on. In particular, this high temperature reducing atmosphere also imposes the devolatilization of lead and zinc. This means that we have the possibility to have no more zinc and lead in this leg, and the possibility to, no hazardous heavy metals. We made a specific study taking into account official documents from Japanese government about 40 plants in Japanese plants and 45 European incinerators. This is the distribution of zinc, 50% in bottom ash, 50% in the air pollution control residues, while in the case of gasification, less than 1% is in the slag. This means that in plants as this, which are the largest gasification plant in operation in Japan, has the possibility to produce a very, compared with municipal solid waste incinerator, here there is all the lead and zinc into the bottom ash. Here there is only in the fly ashes, and no zinc and lead in the slag. Then the slag can be utilized for a concrete block, interlocking block, asphalt paving, and also as eco-sand for some agricultural utilization. And there is also the possibility to expand the conventional boundary conditions that are typical of a waste-to-energy plant, that are the possibility to balance all the waste and RDF, but have to produce bottom measure that have to be treated and so on. In the case of this kind of plant, you can have the possibility to utilize sludge, to utilize clinical waste, to treat also some reclamation waste. This expanded the boundary condition. There is the immediate recycling without any treatment of the slag, and we are very close to a zero waste option that also allow the possibility to increase the gate fee, to reduce the cost of landfill, but also to reduce the necessity of landfill. In Japan, this is a very big problem. This is another plant that is in operation now are about 8 years, and this system allowed to reduce of about 90% the final the amount of material sent to landfill compared to the previous conventional incinerator plant. I have a couple of minutes. 3 minutes. He said 3 minutes. I accept 3. There is some information about this plant from Finland in Lahti energy plant. Is a circulating fluid bed gasifier with a good idea of intermediate stage of gas cleaning. After the gasification, there is a cooling system and a new, particularly innovative system of filtering in order to have a gas, clean gas to be burned in gas-fired boiler. This means that the gasification is carried out at typical temperature of fluid bed gasifier. It is a cooling, the syngas is cooled at up to about 400 degrees C. All the dust and chlorine is eliminated in this step, and this means that they have a so clean gas that they can increase the steam parameter up to 120 bar 540 degrees C. This means higher efficiency, lower fuel cost, the possibility to, again, co-gasification, then less expensive materials in the boiler. These are the crucial part of the cooling and the filtering. Obviously, this is a particular filtering with mineral bags, metal bags, and this is where the additives are injected here to reduce the chlorine content and to increase the steam parameter up to the value I mentioned before. This is the gasifier. This is the one of the 4,000 filter elements that are cleaned by a jet of nitrogen. This is the gas-fired burner. And finally, this is just a picture to indicate the possibility to consider not only the biogas road, that is an excellent road for biomethane production from anaerobic digestion and upgrading of the biogas, but also the biogas gasification and the catalytic methanation. This could be very interesting, not only because the capacity increases so much, from 10, 15 megawatt up to 100, 200 megawatt of produced biomethane, but mainly in terms of carbon to biomethane efficiency. That is the principle of carbon recycling economy. I mean that we can move from 0.15, 0.2 carbon to biomethane efficiency to up to 0.4 carbon to biomethane efficiency. This is very interesting. I have no time to show you the details of this plant that worked for more than 8,000 hours in the last year, but with a very interesting system for reducing the tire production by adding potassium and sulfur in a very interesting, innovative way. And there is now the necessity to make this system also economically convenient by producing not only biomethane, but also hydrocarbons and in different configuration. So, in conclusion, gasification plants may accept a wide variety of wastes and biomass, including bottom ash from incinerators, appear suitable for waste to resources, waste to fuels, and waste to products. In my opinion, is the thermochemical conversion process that better supports a carbon recycling economy. Let me thank you again and to ask you, all the participants, the people, academic colleagues and people from industry to present contribution to the journal Waste Management. I am one of the new editor-in-chief. Some of the colleagues that are in here today are in the editorial board and are associate editor or reviewers of the journal. It's the most important journal in the field, and we need our high-level contribution. Thank you.
Good afternoon, Professor Anderson, and fellow attendees and panel. Thank you for your presentation. My question is for Mr. Keith Sinfield. First off, I'd like to say, go England for the World Cup. My question is regarding the use of organic products for land application from MBT facilities in the UK. Perhaps you could shed some light as to why the UK does not permit the use of organics derived from MBT for land. Is it specifically related to the quality, that it's not feasible or a product cannot be produced that has comparable quality in terms of trace metals and inert material to native soil or other compost?
Okay, can you hear me? Yeah, good. It's a really good question. It's one that we've wrestled with for the best part of 15 years now, from the very early days of that small plant in Scotland I showed you, where that was its output source, was to use this material. Our regulators, the Environment Agency and SEPA, the Scottish version of the Environment Agency, have some strong views around the risk with that material. So whilst we can make a nutrient-rich material, so in terms of beneficial use, we can remove the glass, we can remove the plastic contamination, we can control the heavy metals, but not entirely. So, for example, zinc, copper, lead are always a challenge with their threshold limits. But then if you look at the soils we're applying to it, you may find higher naturally there or from contamination from previous land uses. So it's a conservative approach. It's an approach they've taken. We don't know what else is in there. And there's a lady called Nina Sweet, Dr. Nina Sweet, who looked at this for the Environment Agency as an advisor, a policy advisor for a number of years. And they identified through research with a number of universities other things that could be in the waste stream that could potentially be bioaccumulating. So up to 800 different compounds that could be in domestic black bag waste. So the challenge is we don't know what the long-term effect of applying those to land is, and therefore we shouldn't. So it was a very conservative approach. So it really has come down to the fact, unless it's source separated, as in SSO or leaf and yard waste, which can be applied to agricultural land, MBT derived or non-source separated derived organics can only be used on non-source crops. So that was really the reason behind it. It's quite a conservative view.
Thank you.
Thank you all for your presentations. Dr. Arena, your term carbon recycling economy seems to be another part of that, another side to the same coin that we're talking about in our pursuit of a sustainable economy. So that whole carbon recycling economy really is a key touchstone for me. Keith, just if you could perhaps draw the Canadian connection to Renewi and some of the work that you're doing in Canada.
Can you hear me? Yeah, good. Renewi owns Orgaworld, in effect. It's a subsidiary of the Renewi business. So I work with the Canadian team. We have 3 plants in Canada, from London, Ottawa, and the new plant in Surrey. And that's really very much focused on source separated organics. and focusing on that. So I support them in that basis in terms of technical and engineering. And also some market history we have. We also operate similar facilities in the UK on soil separated materials, both AD and conventional in-vessel composting. So the link is really through that. It's really an organics-focused business here, but clearly for the purpose of this, I was asked to speak in terms of some MBT experience, and certainly from the UK, which hopefully I've shared today.
Just a quick question for Mr. Sinfield. Could you please just define what SRF is?
Recovered fuel.
Sorry?
Solid recovered fuel. So it's a combustible
Solid recovery?
recovered fuel.
New
Okay.
acronym of the
It's an acronym, yeah.
refuse-derived fuel.
Yeah, no, I know
with-
it's an acronym. I'm an engineer, and usually
Okay.
we'd like to try to define
So
the acronym when you
it
use
is a fuel that has a specification, as opposed to RDF, refuse-derived fuels, which
Yes.
doesn't really. So there was a number of committees and a SEN standard, a European standard for what solid recovered fuel was. It's very wide-ranging because it can mean many different things, but it's a fuel with a specification. Ultimately, though, it's what does the off-taker want, and I'll make you a fuel to suit your off-take thing. So it's just a higher quality fuel than just shredded refuse-derived fuel.
Thank you.
May I have a question for Kit?
Hope it's an easy
Kit,
one.
yes. In my opinion, mechanical biological treatment is a type of plants that has a sense only in absence of a good, I mean good in quality and in quantity, level of separate collection. When and where a good separate collection is carried out, each family works as the best mechanical biological treatment facility. So we have to decide, in my opinion, what we want. We want to increase in quality and quantity the separate collection, or want to have to invest in mechanical biological treatment. I believe that the quality of the product produced by good household separation is incredible higher than that of mechanical biological treatment. So if we cite Sweden and Germany, and also a large part of Italy, where for instance in Campania we are about 57% of separate collection, not recycling, then it is not more useful to speak about mechanical biological treatment. Mechanical biological treatment, in my opinion, is a good system for countries as China or Malaysia or India, where it's very difficult to organize a separate collection. I would like to know your opinion.
I think we could consider where we came from. As I said in my presentation, we started off being predominantly a landfill-based solution. So we were the Chinas of 15 years ago. So MBT was a quick solution to get quick leverage in terms of doing something not landfilling.
Quick solution. Okay? Perfect.
So do I see the most effective way of managing waste? I completely agree with you. If we can separate it at the curbside, that's what we should do, and that's where our focus should be. So the more we can separate in a sustainable way, but let's be honest, it has to have a market. There's no good separating things that don't have a market. Film plastics is a really good example at the moment. We can't sell that. We pay to get rid of it.
So
What
it's
do
a
they do with
technology
it?
for the transition.
So it's a transitional technology. But how long's transition? It's not 5 years, it's not 10 years, it's probably 25, 30 years. Even the best performing authorities in the UK, and I serve one of them, has 62% recycling performance this year, pure recycling. That's looking at organics, source separated curbside in multiple streams. It still has an MBT plant, because it still has a huge pile of other materials that we can drive value from. And by driving value, it's not just shoved in a mass burn incinerator. We're still separating glass and stone from it. We're still separating plastics from it. We're still separating 3% of metal input. So there is further benefit you can gain from that. It also allows us to use the energy in a different way. We actually support a local industry through a cement kiln. So we're diverting their use of coal to a sustainable material, which obviously they can then claim emissions trading credits from the European Union. So it's a tradable commodity then, carbon reduction program, that allows them to shift their production cement, actually makes it viable in the UK still. Part of the reason is we're paying them to burn our SRF as opposed to them buying coal. So economically it's good for them, it's also environmentally closed loop in terms of it's all happening in the same district.
Thanks.
So I agree with you, it is definitely transition.
One last quick question.
My last question, it's related to SRF again. Does the cement, well, you mentioned that chlorine content is problematic for the cement industry. Does the cement industry possess the technology to accept SRF with higher or elevated levels of chlorine?
Probably yes, but it's expensive. So you're then scrubbing flue gases. So the kilns we serve are, some are as old as 30 years, some are relatively new. So they have a HCl limit on their emissions, hydrogen chloride limit. So all we're trying to do is make sure they're within their emissions limit. So low chlorine for them is good. Why? Because they also take solvent recovered fuels, so liquid solvents. They tend to, some of those have quite high chlorine loads. So they're looking at their overall fuels balance of the types of material they can take within their plants.
Thank you.
One last quick question.
It wasn't a question. I just wanted to comment on the chlorine. The gentleman was talking. It's not just the emissions. It's also that there's like a chlorine recycle that impacts their product.
Absolutely correct. Yeah, so the salt bypass on the kilns as well. You're right. That's a very fair point.
Yeah, chlorine. Yeah. Okay, I think we'll bring this session to a close. I'd like to thank our speakers once again for bringing up some interesting and important points about technology innovation, the need for government and regulatory drivers, and especially the need for products that we can actually implement and use.